by chance? Everything all good? Okay. So yesterday we had stopped by talking about quartiles. So we were looking at measures of relative standing, and percentiles are one common measure of relative standing. And the reason that percentiles can be useful is because, unlike the standard deviation, percentiles are resistant to outliers. And so when we have data that has skewness in it, one way that you can compare things is by looking at percentiles, or specifically we usually look at quartiles. So the quartiles are the points that divide your data set into fourths. So when you're analyzing a data set, especially quartiles really help with comparing two populations. So anyways, we looked at an example. So we looked at collision data, we calculated the quartiles, and then I was showing you that there's a concept called the interquartile range. It's just the range of the middle 50% of your data. By itself, it's not very interesting, but the most common application of IQR is to test data sets for test them for possible outliers. So anyways, so you establish a lower bound and upper bound, and then you just go back to your data set and see if anything is outside those boundaries. So for the collision coverage data, we did that. We established a lower bound, we established an upper bound, and then we found out that at least one of those claims is a potential outlier because it was above our upper bound. Yeah? Okay. So quartiles are useful in that way. Quartiles are also really useful. We put them together with the median and the min and the max to create what's called the 5-number summary. So we got median, Q3, and the max. These create the 5-number summary, and this is a common set of numbers that we use to compare distributions. Like for example, I did some work where they were looking at, it was a gender discrimination lawsuit for a company where they had men and women in the same position, and one of the ways that the lawyers were arguing that gender discrimination is occurring is they looked at the 5-number summary for the distribution of women in that position and the distribution of men in that position. Okay? And since those are resistance against outliers, those are good markers to look at to compare two different distributions. And so, anyways, so the 5-number summary on its own, not super interesting, but we can calculate it. We already pretty much did, right? So for our collection here of claims, right? The min and the max are obviously the easiest. So you get this. Your max would be 21,147. The median we calculated, what was it? We calculated that yesterday. It was the average between these two, wasn't it?
Was it 3,990?
That was the IQR.
Oh, that's right.
Yeah. It was like 18 something, wasn't it?
1805, yeah.
1805? Something like that? Is that right?
Yeah.
Okay. And then we calculated Q1, 1, 2, 3, 4, right? It was here. 1, 2, 3, 4, it was here. So it was 735 and 4668. And so you'll look at, so like then if you looked at claims, say like maybe this was claims from 2017, then maybe you pull the data from 2018, you can compare the 5-number summary to see if it looks like there's some drastic difference in the distribution. And the numbers are fine, but kind of like we saw at the beginning of Module 2, tables are interesting enough, but we usually like to look at graphs if we can. And the 5-number summary lends itself to graphs really nicely, and the graph we create from the 5-number summary is called a box plot. So you may have seen box plots before we created them. But box plots, sometimes they're called box and whisker plots. The idea is, and you can run them horizontally or vertically, but to construct a box plot, essentially what you do is you create a box, and the box is going to run from your first quartile to your third quartile. Okay, and then you put, here, you put a line wherever your median occurs, and then you just send whiskers or lines out to the max and the min. So like wherever your max is, you'd send that out, or down here, you'd send this out. That would be your minimum. Okay. Sometimes you'll also see box plots where what they'll do is they'll create the box plot. So say like from Q1 to Q3. Box plots can also show outliers. So let's say like a data set had an outlier. What they'll do is you'll draw the box plot like normal, but instead of going say like all the way to the min, let's say that your min was an outlier. So maybe you'll include it on the box plot as a star or like a little, X or something. And so then you just extend your box plot down to your lowest observation that wasn't an outlier. So this is a nice way in a data set to show, okay, I'm showing you all the data, but I'm also showing you that I've flagged some of these observations as potential outliers. So I'll show you that I'll show you how it looks in our example with our claims data. Okay. All right. So if you look at our claims data, right, we could do our box plot for our data. So the one thing is you just got to make sure that your, your line here is consistent. So our data goes basically from what, 0 to 20,000, right? So we could say maybe here's 0 and 20,000. It goes just over 20,000, but this will make it easier. So let's see, right in the middle would be 10,000. Then, this would be like 5,000. This would be 15,000. And then, you could go in the in-between. Not that you really need to, but, that would be 2,500 and so on. We really only need this one because our data is all kind of piled up near the bottom in general, right? Because what was Q1 on this data set? Wasn't it like 735, right? So it's really low. So down here at 735 is where our box will begin. Right? And it's going to go up to 4668. So our box is, 4668. And then the median was what, 1805? So that's somewhere down here. And our min is down here near 0. It's just 180. So it has a really short whisker on the bottom. And then the top just goes way out here, right? So you can also tell whether a distribution is skewed or symmetric by looking at whether or not the box plot is skewed or symmetric. Okay, right? And so this data set is obviously skewed. In which way is it skewed towards? The tail, which is to the right. Okay, so if you were to look at this, you can it's kind of showing you what the histogram would look like even, right? Everybody would be kind of all piled up down at the bottom, and then you'd have a nice long tail reaching out to the top. And the other thing is, like, you can see, like, up until the top of the box, that's the lowest 75%. So, like, the lowest 75% are all piled up down there, and then the top 25% are way spread out. So this is a pretty skewed distribution. If you remember, though, we flagged this one as an outlier. So if you wanted, you could display this similarly. There's no outliers on the bottom, but we could go, same idea. But what we do is we would only take our whisker out to the biggest value that wasn't an outlier, and then we would just flag it here at 147. So, and you can see it still has a skew distribution, but if you pull the outlier out, it's not nearly as extremely skewed, right? So if that really is an outlier, then actually there's a good chance that the box plot on the bottom is really more representative of how the claims actually fall out, because that person may have actually been a pretty big outlier in the data set. So, yeah. Make sense? Everybody feel like they could draw a box plot? I have faith that you could draw a box plot. All right. Okay. So basically, there's graphical summaries and numerical summaries that you can create for data sets, and it kind of depends on what type of data you have. And you always want to be thinking about whether your data has skewness or outliers in it, because the mean and the standard deviation are very good for symmetric data, but they are really sensitive to outliers. So if you have skewed data, then you should really probably stick to things like medians, quartiles, box plots. It's going to be a safer bet. All right. Is that what we got? Is that the end? Oh, that's the end. Look at that. So I went to, I printed a bunch. I sent all this stuff to the printer to bring for you guys to practice with, and then I went to the printer and they weren't there, so I don't know what happened to them. But I didn't have time to reprint them before I came to class. So I'll bring some stuff in to work on tomorrow. I don't really have anything else today, but what I will do is, if you want to stick around, I have this little standard deviation practice worksheet. And so if you wanted to stick around, I'll just pull it up on the projector and figure out, if you haven't figured out how to do like means and standard deviations in your calculator, then you can stick around. I can show you how to program this stuff into your calculator so you could use them on your quiz. If you know how to use your calculator to do this stuff, then I would say you can go ahead and go. I don't really have anything else to do because, like I said, I don't have this stuff printed out. But if you want to stick around and give these right, or if you want to do it with the formula, you can do that too. So this is just the practice worksheet I have on there. The answers are also online, so you can look at the answers later. But anyways, so stick around, learn how to use calculator if you want. Or we just had a 15-minute class, so I'm sorry I dragged you onto campus for that. I was expecting to have more stuff to do today, but I'll make sure we have some stuff to work on tomorrow. And that's all I got for you. So hopefully you didn't just drive to Pasco just for this 15-minute session. And if you did, I apologize. So.